Pods crashed every 5 minutes with OOM-Killed. The team spent hours profiling heap dumps, but the real culprit was a mismatch between the container memory limit and the JVM heap size. Here's exactly why. Welcome to TheCodeForge. Before we dig into that production issue, let's design a code deployment system. A code deployment system is the automated pipeline that moves code from version control to production servers, handling build, test, rollout, rollback, and traffic shifting with minimal human intervention. Think of it like replacing the engine on a flying plane. You bring a second plane alongside, transfer passengers one by one, and if the new engine sputters, you switch back instantly. Before we talk patterns, understand the failure modes. The most common mistake is treating deployment as a single step: build, push, restart. That's how you get a full outage when the new code has a bug that only manifests under real traffic. Never deploy by SSHing into production and restarting services manually. This pipeline builds, copies the jar via SCP, restarts the service, and verifies with a curl. But it's a house of cards. Single server, no rollback, no traffic draining. If the new app has a memory leak, it crashes 5 minutes later with no automated rollback. Blue-green deployment is the simplest zero downtime pattern. You maintain two identical environments: blue, current production, and green, new version. You deploy to green, run health checks, then switch traffic from blue to green. If something goes wrong, you switch back. The key insight: the switch must be atomic from the user's perspective. This CloudFormation snippet sets up two target groups for blue and green, and a listener rule that forwards traffic to the blue group. During deployment, you update the listener rule to forward to green. Traffic switches in under 1 second. Canary deployments reduce risk by routing a small percentage of traffic to the new version before a full rollout. Start with 1% of users, monitor error rates and latency, then gradually increase. The magic is in the traffic splitting. You need a load balancer that supports weighted routing. This Istio virtual service routes 1% of traffic to the Canary subset and 99% to stable. You can adjust weights gradually. If error rate spikes, set Canary weight to 0% automatically. Rolling updates replace instances one by one. Kubernetes does this by default. It spins up a new pod, waits for it to become ready, then terminates an old pod. The advantage: no extra infrastructure cost. The disadvantage: during the rollout, both old and new versions serve traffic simultaneously. This Kubernetes deployment uses safe rolling update settings: max surge, 1, only one extra pod at a time, and max unavailable, 0, never terminate a pod until new one is ready. The readiness probe must check that the app can serve traffic. Database migrations are the #1 cause of deployment failures. The problem: code and schema must be compatible during the rollout. The solution is the expand contract pattern. First, expand the schema to support both old and new code, deploy the new code, then in a second deploy, contract the schema. Phase 1 adds a nullable column and keeps the old column. New code reads the new column first, falls back to the old one. Phase 2 drops the old column and makes the new column not null. Never do this in one deploy. A rollback is not just reverting the code, it's reverting the state. If the new version ran a database migration, rolling back the code might leave the schema in an incompatible state. The safest approach: make every deployment reversible with a down migration. This migration includes both an up and down script. The deployment script runs the up migration, deploys code, and if health checks fail, runs the down migration and rolls back the code. Never deploy a migration without a corresponding down migration. Health checks are your deployment's immune system. A readiness probe should check that the application can handle traffic, database connectivity, cache connectivity, and any critical downstream services. A liveness probe should check that the process is healthy. They must be independent. This Spring Boot controller has two endpoints: ready checks database and cache, returning 503 if unavailable. Health simply returns 200. Kubernetes uses ready for readiness probe and health for liveness probe. Feature flags let you deploy code that is turned off, then enable it gradually without a new deploy. This is the ultimate safety net. You can deploy a new feature to production, test it internally, then enable it for 1% of users, then 100%. If something goes wrong, you disable the flag instantly. This Java code checks a feature flag before deciding which checkout flow to use. The new code is deployed but invisible until the flag is enabled. If a bug is found, disable the flag, no rollback needed. This is the same issue we highlighted at the start. Here's exactly why that happened. After a routine deploy, pods in the new replica set crashed every 5 minutes with OOM-Killed. The old replica set was fine. The team assumed a memory leak and spent hours profiling heap dumps. But the deployment YAML had resources limits memory. 4 GB while the JVM heap was set to 4 GB via XMX 4G, leaving zero room for JVM overhead like metaspace, threads, and GC. The container hit the limit instantly. The fix was simple. Set XMX 3G in the JVM args and keep resources limits memory, 4 GB. Always leave 25% headroom for non-heap memory. After this change, pods stopped crashing and the deployment succeeded. This is the exact mistake from the incident. The container memory limit is 4 GB, but the JVM heap is also set to 4 GB. This leaves no room for JVM overhead, causing immediate OOM-Killed. Always leave headroom. Health checks must test the full application stack, not just a ping endpoint. I've seen a team use health that returned 200 even when the database connection was dead. Use a health check that queries the database and checks a critical external dependency. The max surge and max unavailable fields shown in the RollingUpdate example are from the app's v1 API, which is stable since Kubernetes 1.9. If you're using an older cluster, pre-1.9, these fields are not available. Always verify your cluster version before relying on these settings. The article mentions monitoring error budgets, but doesn't show how to automate rollback. Here's a concrete example using Prometheus and a simple script to trigger rollback when the error rate exceeds a threshold during a Canary deployment. During a blue-green or rolling deployment, old instances may hold open database connections. If you terminate them abruptly, you can cause connection pool exhaustion on the database. Always implement a graceful shutdown that drains connections, e.g., via SIGTERM and a pre-stop hook before terminating old instances. When things go wrong, start with these commands. Check pod logs and events to diagnose the issue. If OOM-Killed, increase memory limits or reduce heap size. If liveness probe failing, check the health endpoint and adjust probe parameters. Let's run through some common interview questions. How does Blue-Green handle incompatible DB schema? It doesn't. Use expand contract pattern. When choose Canary over Blue-Green? When can't afford double infra or want real traffic validation. What if readiness probe fails during RollingUpdate? Kubernetes stalls rollout. Check probe endpoint. And a few frequently asked questions. What is the safest deployment strategy? Blue-Green for instant rollback, but requires double infra. Difference between Blue-Green and Canary. Blue-Green switches all traffic at once. Canary shifts gradually. How to handle DB migrations safely? Expand contract pattern with online schema change tools. To recap, Blue-Green deployments give instant rollback but cost double infrastructure. Canary deployments reduce risk by gradually shifting traffic. Database migrations are the #1 deployment killer. Use expand contract. Health checks must be comprehensive and independent. Feature flags let you decouple deploy from release. Ready to go deeper? Up next, design a distributed cache, then design a distributed locking service, then design a flight booking system. Find them all at TheCodeForge.io. Thanks for watching. The full article and code examples are covered in detail at TheCodeForge.io.